Hey guys, welcome back. Today we're talking about the two sections that you read about factors affecting reaction rate, including catalysts. So the first thing that you can do if you wanted to speed up a reaction would be to increase the concentration of reactants, which makes a lot of sense because the more particles you have in a given space, the more collisions you're going to have, and the more likely that those collisions are going to be successful. Um, you can do that with a higher molarity of an aqueous solution. You can do it with a higher concentration of gas. You really can't change the concentration of liquid or solid too much, but it would definitely work for aqueous or gas. Number two, this one only works for gases. If you increase the pressure of gaseous reactants, so essentially pack them into a smaller tank, that's going to increase their pressure, giving you more collisions. And the more collisions you have, just like the previous one, you're going to be more likely to have collisions with the correct orientation, and therefore a faster reaction because more particles will be reacting. The third way to increase reaction rate is increase temperature. So the faster the particles are moving, very simply, the the greater number of them you'll have overcoming that activation energy hill. So we're talking about this uphill right here. The more of them you'll get over that hill, the faster they're moving. So most reactions happen faster at higher temperatures. Number four, to increase surface area. So if you disperse reactants, like if it's a powdered reactant, you disperse it into the air, like sawdust becomes very flammable, which is why in like a wood shop, like even at Parkway North, you have to have you have to have vacuums that pull the wood particles out of the air after you've used a sander or a saw, and that's to keep those wood particles from building up in the air and becoming extremely flammable. I'll embed a link in the Edpuzzle to show you a video of it's kind of goofy. It's a commercial for coffee showing what you can do with coffee creamer, which is not super flammable unless you disperse it into the air. It's the powdered stuff. Yeah, people don't use it as much anymore, but basically it's like an imitation creamer that you put in your coffee. It becomes extremely flammable when you disperse it in the air because the particles can get to each other and therefore collide more and react more. The last thing that we can do to increase reaction rate is add a catalyst. So catalysts can do this a couple of different ways. The main ways are by essentially lowering the activation energy. And you can either do that by creating a activated complex that has lower energy. So when you look at, let's say you have a reaction with a big activation energy hill, and you add a catalyst, that catalyst might provide a smaller activation energy hill because it's combining with the activated complex to make it more stable and bring its energy down. Now, in order for it to be a catalyst, though, that catalyst um, has to be lost before the reaction's over. Meaning that if I put a catalyst in order for there to be no net change in the amount of catalyst, um, it also has to be spit out. So the reaction uses catalyst, but then also produces catalyst so that there's no net change in the catalyst. And that is the definition of a catalyst. It speeds a reaction without getting used up. So the enzymes in your cells that speed reactions and allow you to basically stay alive at the relatively low temperature of 98 or 99 Fahrenheit. A lot of the reactions that occur in your body that keep you alive wouldn't normally happen at that temperature. Um, but with the presence of enzymes are catalysts, they're able to happen, and because you're lowering that activation energy hill. The other thing that can happen, and this was explained in one of the videos embedded within the CK12 material, is we talked a little bit about multi-step reactions. We're going to talk more about it next week, but um, if you think about Hess's law, where you can basically take an overall reaction and talk about it happening in two or three steps, or sometimes even more, um, those steps can sometimes involve a catalyst. So where your original reaction may have had a big activation energy hill to overcome, introducing a catalyst might add a step or give you some different steps. But if those steps have lower activation energy, like let's say this adding a catalyst takes two more steps. Let me redraw that. I didn't do that very well. So let's say adding a catalyst to a reaction takes a couple more steps. But notice neither of those hills are as high as the original. That reaction is going to happen faster. And and then an example of that would be when you put hydrogen peroxide on a cut, it bubbles. If you've ever noticed that before, bubbles are in that case oxygen. All you're doing is you're speeding up the breakdown of hydrogen peroxide, which is H2O2, um, with the catalase enzyme in your blood. So catalase is the name of it. And the catalase I'm not putting in the balanced equation or in the equation because it doesn't get used up. It's going to get kicked out of the equation or of the reaction in the end, and therefore it can go on and find another H2O2 molecule to bind with and catalyze. And then you're going to get H2O and you're going to get oxygen. And actually, the interesting thing here is that oxygen is why you put hydrogen peroxide on cuts as an antiseptic, because most of the harmful bacteria that you're trying to avoid in your cut so that it can heal and you don't get an infection are going to be poisoned by oxygen. They're anaerobic. So that's why we do that. And the blood does a has that catalase in it to speed up the breakdown of the hydrogen peroxide produced at oxygen. Um, and if you didn't do that, if you just left the hydrogen peroxide open out on the bathroom sink or whatever, left the cap off the bottle, it would eventually do this. You would eventually end up with a bottle of water and a bunch of oxygen that's been released into the atmosphere. But it would take a long, long time because it has a larger activation energy hill. So hope that makes sense. And we will see you guys next week.